Thanks everyone. Just the last bit of this whole seminar series here. Um, so a lot of discussions about how do we manage what are the new rules for nitrogen management for groundwater protection. Kevin put together uh, some nice data together on nitrogen budgeting, and this sort of rounds it out. This presentation will round it out. So obviously this group has funded quite a bit of research on optimizing nitrogen rate, source timing on sweet corn and snap beans, and so we can work across how efficient can we be. And so a lot of what I'll present about is about, well, what are the things that we can control, and what's the net effect of our nitrogen management. But I want to also talk about this concept of nitrogen use efficiency. So Kevin put together has this full nitrogen budget. I think a simpler approach too, from an agronomic perspective, would be these assessments of nitrogen use efficiency. So there's two simple measurements that anyone can do, and we're doing this with a lot of different cropping systems in Wisconsin. Is the idea of partial factor productivity and the partial nutrient balance. I know they don't have catchy names, but so the first one is just simply what's your yield divided by the nitrogen you applied. And the second one is what's the nitrogen removed in the harvested portion of the crop. So we'd have to get either a measurement or an estimate of the nitrogen content of the amount that's removed. So if it's corn for grain, the entire ear for sweet corn, the pods for snapping. Divide that by the nitrogen that you apply. So we've been doing this with our Discovery Farms program, specifically related to corn for grain. And we've developed some benchmarks. So these are outside of the central sands, but it gives you kind of a sense of what we can do with this type of data. We're working on actual farmer fields. So with the idea that every farm we're working on, the farmer is setting out to optimize his production system. And we measure the yield, and we also get the nitrogen content of the grain, and then we get the farmer to tell us how much nitrogen they applied. So in corn, it's quite simple. Then we can put together some data like this, and we can do something called benchmarking. So what's the average use efficiency for corn in Wisconsin, even outside the central sands? And so here we're getting a value of 73 pounds of grain. So it's 1.3 bushels we're getting for every pound of nitrogen that we're applying. But that's on average. So we can put some stuff into quartile. So 25% of all the farmers are actually getting 1.84 pounds or 1.5 bushels or more per pound of nitrogen they're applying. So the more bushels you get for the amount of that you apply, the more efficient you're going to be. So we can use this then to along with fertilizer recommendations, say, okay, well, it's fine that you're using certain fertilizer recommendations, but how would you decide if you wanted to change anything? What would be that metric? And this would be that metric. If you're below average, that would give you some indication like, oh, well, maybe there's something else I need to be doing to get more value for the nitrogen that I'm applying. And one of the big things is increasing yield. So, there's two factors in this use efficiency assessment. One is the fertilizer you apply, and the second is your yield, right? So looking at this relationship between yield, and so we kind of lumped everything into these 10 bushel yield groups here. And you can see that on average, the bigger yields tended to be related to higher efficiencies. So it's not just about reducing nitrogen, although certainly there's cases where we're not seeing nitrogen accounted for, or certainly some over applications, but it's really about how much can we grow and how much nitrogen can we take up and remove from the system. So that's on the yield side of things. We can also look at this partial nutrient balance. So this is the nitrogen removed in the harvested portion of the biomass divided by the nitrogen applied. And so we have this for corn grain, and I also included corn silage as another example. So on average, right here, so this average value, 0.77, or you can just think about it as a percent, 77% of the nitrogen that's applied is the equivalent is removed in the grain. So it's not saying that this is the amount that was taken up, but on average, we have 77, we have this input, and roughly 77% of that equivalent is removed. Again, once we get closer to, ideally we like this number to be in a perfect thing above 90%, but we're seeing about 25% of the farms in Wisconsin achieving close to that or greater. So with the high efficiency fields. Now with field corn, or corn silage, it's a little bit different, right? Because we're removing that entire biomass. So we're always going to be removing more. Typically, we're going to be removing more nitrogen than we're applying, just because we're the amount of physical biomass. So we tend to see we're removing 110% of the nitrogen that's applied. So we're removing everything that's applied plus a little extra. When we talk about that, that's more about, and we can be stealing a little bit from the soil organic matter in those situations. So in any case, it gives a nice range. It gives some nice benchmarks of where we're at. And then we can also flip it, this partial nutrient balance. Instead of dividing the numbers, we can subtract them. So the nitrogen, so this is the partial nutrient balance, N removed divided by N applied on this axis. And on the y-axis is the nitrogen balance. That's the nitrogen applied minus the nitrogen removed. So this gets, it's a simplified version of Kevin's budget. And so we can see when we look at this average value for getting about 0.7, 0.77, 0.73, somewhere in there, we're getting our nitrogen balance then is less than 50, maybe closer to 40 pounds per acre. So that's at some levels, that's very good. Depending on where you're at and what the regulations are, you may still need to have that a little bit lower. So we can use this to figure out where we're at in the state, and then we're going to track these over time. And also, this is the data that farmers could use to make decisions about how to improve management. But of course, that's not the exact metric that we always want to use. Sometimes we might want to use this nitrogen uptake efficiency metric, and that is how efficient is the actual fertilizer when you're applying that fertilizer. How much of that fertilizer is actually taken up by the crop? And for that, you'll need a zero nitrogen plot. And this is going to be really important when we look at sweet corn and snap bean. So the uptake efficiency, you need to know how much nitrogen is available to the crop from sort of the background levels. And in essential sands, that'll be a little bit from the soil organic matter, and then from that background and from what would be applied through the irrigation. And then we would look at something like this. So on the left here, we have this is the total nitrogen uptake in a fertilized plot in the sweet corn. We might, and this would be our, then we want to calculate the total nitrogen uptake from an unfertilized plot. And then we want to know that difference, right? So it's this amount of nitrogen, this extra nitrogen in terms of uptake, that is the fertilizer nitrogen that was used. So we need to take the total amount of nitrogen in the biomass when it's fertilized. You subtract off what's in a non-fertilized plot, and you divide that by the nitrogen that's applied. So when we do that for field corn, so intensively monitored corn grain fields, we have a median uptake efficiency of almost 60%, with, again, 25% of the farm fields we tested got 80% or higher. Those are pretty high values. So it is possible to be pretty efficient with the nitrogen that you're applying, but that'll vary greatly based on a lot of different reasons. So for example, right, if you have a system that has a lot of nitrogen supplied by organic matter, it has a lot of nitrogen supplied through irrigation, that's increasing those yields when we're not putting any extra fertilizer out, you'd have to cut back on your total nitrogen application to have a high efficiency. So in any case, we can look at these, use these as kind of some metrics to gauge against. So 60 to 80% for uptake efficiency. So then let's give some examples for sweet corn and snap beans. So this is work that's based on several years of funded research to optimize nitrogen rates. And here, there's a comment about split applications, but for all of these evaluations we're working across split applications. So we're not testing a single application versus two applications, which they tend to be applying 3 to 4 times plus a starter fertilizer. So we're already setting up our rate trials to try to be as efficient as we can with those splits. So based on some previous work, we're finding some optimum nitrogen rates can occur between 160 to 200 pounds per acre. So I'm going to pick 200 pounds per acre for an application rate. And we're able to kind of work across this range of these higher yield goals. So for example, this is just one site here that I picked that kind of show the example of these things. So we have 3 different varieties. And when I applied 200 pounds of nitrogen, I got these 3 different yield levels: 7.3, 8.9, 9.6 tons per acre. in these studies, I collected the ear, and I know how much nitrogen was removed in the ear. Plus, I know the total amount of nitrogen in the plant at the time of harvest. So we have those two sort of values. So for the partial nutrient balance, so we'll look at all these metrics here. But with these, see here, let me annotate. So starting with the partial nutrient balance, right? That's the N removed minus the N applied.
Matt, if I could
In this case,
interrupt, I
with the
think
sweet
maybe your
corn,
slides
not
are frozen.
what's that?
I think maybe your slides have frozen.
Oh, did
We're
I
on the slide
open
that
up
says if
with
you want to get an estimate of how much.
what are you seeing now?
Same thing.
All right.
Maybe stop sharing and reshare. Isn't the internet great?
What do you see now?
Right now it says Matt Ruark has started screen sharing. Oh, now we have a sweet corn field. We did.
Oh, okay. Okay. Well, I'll just keep doing this
Just
over.
went away though. Now I see it again.
You see a sweet corn field?
I'm a little dizzy, but yes.
Okay. I mean, sometimes you just have to blame the moderator for all of this.
Sure, go for it. Thank you.
Okay. So now you're seeing a table with a lot of numbers on it.
Correct.
All right. So 3 varieties. We have 3 yields that we achieved with 3 different varieties. We applied 200 pounds. So our partial nutrient balance, so that's the N applied, sorry, N removed minus N applied. In this case, we're getting it's kind of this range of 30, 40, maybe close to 50% of the nitrogen that was applied is removed. So these are much lower values than we would get with field corn, right? But obviously so we're not getting as nitrogen of the total amount of N that's physically removed from a sweet corn field, even when under high yields, aren't as much as in a corn grain field. However, when we go to this calculation of uptake efficiency, we tend to have very low yields and very low nitrogen uptake for sweet corn when we're not applying any nitrogen. So we get this range in values of this uptake efficiency, which can be quite high. So 70, in one case we had 50, that was the lowest one, but in some cases 69, 76% of the nitrogen we applied was actually utilized by the crop. So for sweet corn, we have it goes 2 different ways, right? The uptake efficiency is high. The utilization of that fertilizer is high, but we're not removing necessarily a lot, but the crop's using it. And then go to the end here, this nitrogen balance at the end, unfortunately, because we're not removing as much, we have these really high nitrogen balances because there's so much nitrogen left in the system as the stalk, right? We're harvesting, it's still pretty green. There's still a lot of nitrogen left in that system. And these numbers are similar to what was reflected in Kevin's estimates in his budget. All right, so this creates some trickiness, right? What's the metric for efficiency for producing sweet corn? Is it that the fertilizer that you're applying is actually utilized by the plant? Or is it this end of season nitrogen balance where you have a lot of nitrogen left over in crop residue that leads to that off-season nitrogen losses? Where does that nitrogen end up? And how do you have to, or, trying to capture that becomes the challenge for maybe meeting some water quality goals. And this is just some extra data just to show that on average, we're seeing about 35% across all of our sites and all of these studies for this partial nutrient balance. We're only removing about 35% of what we're applying. But across the board, once we're at that optimally efficient level, we're getting that 60 to 70%. We're seeing 55 on average, but for those efficient rates, 60 to 70% efficiency, 60 to 70% of the nitrogen that you're applying is actually used, which tend to be a little bit higher than average than compared to field corn. But what about the case of a little less nitrogen? So here's the problem, right? Is that when we're working across these ranges, we have this study. I just picked one variety and I picked that 200 pounds. Well, what if I cut it down to 160? Well, I lost a little yield. I did, went from 9.6 to 9, but the efficiencies went up quite a bit, all right? Because I applied 40 pounds less nitrogen. And quite frankly, that extra 40 pounds that was applied, only a small amount of that nitrogen was actually utilized in these calculations. So it drops the nitrogen balance quite considerably. So it's going to be this that's going to be that struggle of these, especially in these high value crops, right? Is that we have these economic gains, right? It would certainly probably pay to try to add a little bit more nitrogen around this range, but the amount of that extra 40 pounds isn't used that efficiently. Um, and so by not applying it, you keep a much more advantageous nitrogen balance, but you left a little bit of yield on the table. But the other aspect of this too is these are also, these are high yielding conditions. And so the other big trick that, again, that we struggle to rectify is that the idea is you're not going to get high yields unless you put out adequate nitrogen. But putting out adequate nitrogen doesn't guarantee you're going to get those yields, right? So applying a lot of nitrogen, I hope, and getting high yields is a good thing in terms of efficiencies, especially when it comes to uptake efficiency. But if you're getting even lower yields, these balances and efficiencies really can plummet. So again, at an optimal nitrogen rate, sweet corn efficiency. Sweet corn efficiently utilizes the nitrogen that's applied on irrigated sands, but a lot of this nitrogen isn't removed. So then moving into snap bean. So a little bit of those same things. First, I'm going to start with these non-nodulating varieties, right? The ones that respond to nitrogen, and in previous work have this optimal nitrogen range of 80 to maybe even a little bit more nitrogen. So I picked a site year of data. I picked Huntington and Pismo at 80, given it 80 or 110 pounds of nitrogen. And you can see in the Huntington that we didn't see much difference, between the yields between the two rates, but we did see another yield bump between those two rates in the Pismo. So we're looking at about 50 pounds of nitrogen up to 65 pounds of nitrogen removed in the pod. The total amount of uptake can be up to 120, certainly over 100, 125 pounds of nitrogen in the total plant on a per acre basis. So what does that look like? Well, with the Huntington and Pismo, they somewhat similarly to sweet corn, they don't do very well when we're not applying nitrogen. But they also do pretty well in terms of the efficiency. So in terms of the partial nutrient balance, that's the N removed minus the N applied, we're getting that 50 to 60 range pretty consistently. So that's a little bit less than our average for field corn, but certainly a lot higher than what we're seeing for sweet corn. So not quite as efficient as field corn, but the uptake efficiency kind of falls in that medium range too, where it doesn't do quite as bad as sweet corn in terms of what happens when we're not applying nitrogen. But in some cases, so we're getting that 50 to 70 pound range. But cutting to the end of the page here for the nitrogen balance, generally speaking, at economically optimum ranges, we're seeing less than 40 pounds. What we're seeing with 80 pounds of nitrogen, 26 pounds from a nitrogen balance. That's pretty low relative to all the other crops we've looked at. So sweet or snap bean kind of has this other approach where it's well, we're kind of seeing these medium efficiencies for PNB, medium efficiencies for how the fertilizer has been taken up, but by the end, because we're getting high, and these are under high yielding conditions, when we're getting those high yields relative to those high inputs, that the balance still works out pretty well. And also just the idea in the plant, the nitrogen's really, a lot of that nitrogen's in the pod. So that's in the non-nodulating varieties, but the nodulating varieties, this gets a little bit trickier. And I presented this last year. And the idea is the value here is we can't do those same kind of calculations as we can with the non-nodulating varieties, because we have a certain amount of nitrogen that comes from fixation. So what we wanted to test was, again, these are two nodulating varieties in any site year. When we put out 60 pounds of nitrogen, how much of it was taken up? Well, first we want to know if it suppresses nodulation and nitrogen fixation. And in this case, we demonstrated that it did. So in this first year, it reduced it by 40%. The second, or this other variety, it reduced it by cut the nitrogen fixation in half. And so that's actually important because we are seeing some slight yield gains, but we actually want the N fixation to be suppressed to achieve water quality goals because we want that nitrogen that we're applying to get taken up. But if it's still fixing a lot of nitrogen, then the nitrogen that we're applying isn't going to be taken up. So in the end, we're seeing 63, 83% uptake efficiency. So for these high yielding nodulating varieties, even a little bit of nitrogen, we can be really efficient with it. Is the take home message there. So just as a quick summary here, looking at, so this first line here is the corn grain in Wisconsin, right? So partial nutrient balance. I have these in the wrong order. I took all those out. Sorry. Roughly 77% equivalent of the nitrogen that's applied is removed in the grain just based on a simple balance. But we can typically achieve 60 to 80%. Half of the farm fields or more are achieving 60 to 80% of that uptake efficiency of the nitrogen that's applied. 60 to 80% is being utilized. And thus, in most cases, we can have a relatively small nitrogen balance. For sweet corn, though, right, it's the opposite. Low partial nutrient, that we're not removing as much of the N we're applying, but in season, it's utilizing it to a high extent, but we have a high balance at the end. So we can be really efficient with what we're applying in season, but our end of season nitrogen balance is high. Snap bean, kind of a medium uptake efficiency. So not too bad. Not as good as field corn, but not as bad as sweet corn. But then the nitrogen balance is the real winner here, where we're seeing, less than 45, less than 40 in kind of worst case conditions. For most medium yielding fields, these balances will probably be 30 pounds or less. So, and this is all based on actual field measurements. So we have some challenges, and the challenges for nutrient management planning and reducing impact to groundwater are different for sweet corn and snap bean. So just stuff we need to think about as we're moving forward. So that's the data that I have to hopefully put a little stuff in context. I think ultimately we can be efficient, but the idea of what does it mean to be efficient changes, and that's some of the trick moving forward. So with that's what I have for everyone today, and
great,
happy to answer any questions.
Yeah, thanks, Matt. We do have a question from Dan. When do you think the sweet corn residue will release all that N? Fall? Hold most until spring?
And I was thinking about this as I was putting this together. What do we do with that? And I don't know is the answer. That's why there would be there'd be three ways to capture it. One would be to, like, if we could physically harvest all the biomass, that'd be one thing. Two would be to add that cover crop in to try to capture it as it's decomposing. And actually, I probably need to go back. What's the C to N ratio of that sweet corn biomass? Certainly, it's going to be a little bit lower than corn stover thin of a corn grain season. So those dynamics of that sweet corn biomass are still a bit elusive on those breakdown patterns. And the last would be, is it possible? Could we capture it? Could we credit it for that next year? These are some other untested things. But your point is, your main question, we don't have an answer for scientifically. We don't know the dynamics and the breakdown patterns of that sweet corn residue.
Okay, thank you. Yeah, it sounds like between your presentation and Kevin's, there's a lot of work that could be done in the shoulder seasons or in the non-traditional growing season, I guess you would call it. The seasons we haven't paid as much attention to. So, and we have another a comment from Charlie. We got a 40-pound credit from sweet corn on next year's field corn, no cover crop.
Okay.
Yep, and that was shared last week also, I believe. And then Jason Lenders says, similar question to Dan, given 2 weeks ago presentation, when there is some credit to be gained possibly from sweet corn, is there thoughts on varying the credit that would come from snaps, either non-nodulating or normal?
So that's That's a that's a very good question. I would have to do a little bit of data analysis to get a good answer for you. But so there'd be two things: is what's that C to N ratio of that residue that's left over, and if it's relatively small, it doesn't the idea if it most of it came from fixation or not won't matter as much because the decomposition patterns should be probably similar. Um, I suppose the trick is since it's a 60-day crop and harvested so early, how much nitrogen is left? Probably 50 to 60 pounds, maybe even a little bit more in that biomass. So that nitrogen's there. Well, maybe it's a little bit less than that. Maybe it's a little bit less than that. Again, but that I think that creates a lot of unknowns for us. How do we when is it decomposing? When is it releasing? And then what's the best way to capture it? Through cover crops, through crediting, is it stick around to that next year to credit? Or if neither of those would be the case, then literally physical removal would almost be the best. So all these points are really good. We don't know what to do with the residues and how to properly capture that N.